Hi, my name is Brittany Bostic. Thank you for joining me as I present on the use of scanning electron microscopy with energy dispersive X-ray spectroscopy, or SEM-EDX, and forensic validation analysis. SEM-EDX is a combined analytical system that allows forensic laboratories to examine microscopy materials while simultaneously determining their elemental composition. In this presentation, I will cover how SEM-EDX works, why it is useful in forensic casework, and the results of a validation study. Overview of SEM-EDX instrumentation. SEM-EDX integrates two technologies into one platform. The SEM generates high-resolution surface images by scanning the sample with a focused electron beam. At the same time, the EDX detector measures the X-rays emitted from atoms within the sample to identify which elements are present. This dual system design makes SEM-EDX especially useful in trace evidence analysis, where the size, shape, and the elemental signature of very small particles can provide crucial forensic information. Because this technique combines microscopy and chemical identification, it has become a preferred method in examining gunshot residue, paint chips, glass fragments, and other microscopic evidence that may link individuals, weapons, and crime scenes all together. How SEM-EDX works. SEM-EDX relies on behavior electrons interacting with the surface of a sample. A high-energy beam is fired from an electron gun and directed across the mounted specimen. This produces three primary signals: secondary electrons that provide detailed surface morphology, backscattered electrons that give contrast based on atomic number, and characteristic X-rays that reveal which elements are present. These signals help examiners identify what a particle looks like as well as what materials it contains. Because of this, SEM-EDX is considered a powerful technique in forensic science, particularly when a visual match alone is not enough to confidently classify evidence. Microscopic versus elemental analysis. One major advantage of SEM-EDX is the ability to examine both external features and elemental composition at the same time. Microscopic analysis looks at physical characteristics such as size, texture, and particle shape. Elemental analysis verifies the presence of specific inorganic metals. In forensic gunshot residue work, particles that contain lead, antimony, and barium with defined spherical shapes are considered characteristics of firearm discharge. The validation study used both analytical mods to confirm particles were truly gunshot residue. Sample types analyzed by SEM-EDX. SEM-EDX is applicable to a wide range of forensic evidence. It can be used to analyze gunshot residue, small fragments of glass or paint, minerals in soil, synthetic fibers that incorporate inorganic compounds, and residues from explosives. The technique is especially valuable when classifying particles that are too small for light microscopy. In the study reviewed here, researchers collected gunshot residue directly from the hands of known shooters to evaluate the analytical performance of SEM-EDX. The ability to detect, classify, and differentiate these particles makes SEM-EDX an essential tool for firearm-related investigations. Sampling methods for SEM-EDX. Particles are collected using adhesive carbon tabs attached to aluminum stubs. This preserves particle shape and avoids contamination. Minimal preparation is needed, helping ensure the evidence remains intact. The study followed these standard procedures, making the method realistic for routine forensic laboratory use. Results and conclusions of the study. The study demonstrates that SEM-EDX accurately detected GSR-specific elements and particle morphology. It showed how reliability in distinguishing true shooter samples from non-shooters. The results confirm that SEM-EDX meets forensic standards as a validated court-accepted method for GSR identification. The evaluation of the study. The study had several strengths, including clearly defined validation criteria and consistent analytical protocols. The methodology reflected real operational conditions used in forensic laboratories, which supports the external validity of the findings. However, there are also areas for improvement. Increasing both the number and diversity of samples, such as those from different environmental or occupational sources, could help demonstrate how well SEM-EDX performs across more complex case scenarios. Additionally, it expanded statistical analysis would further strengthen accuracy estimates and enhance interpretation confidence. Thank you. I appreciate your time and attention. This concludes my presentation on SEM-EDX validation.